Hi, so welcome to Module 1, which is on percents, personal budgeting, and simple interest. So the book sections that cover these topics are 1.2, 7.1, 7.2, and 7.3. So you can see that at the top of the notes. So a good idea would be to, if you have a printer, print off these notes, or you could just reference them on your computer as you go through the video. And then feel free to pause at any point. If there's an example, try it yourself, and then you could play the video and see me explain it and double check your work. So you'll see on the left here, I've got my graphing calculator up. Now you don't need a graphing calculator for this course. This is really nice software to use. So that's why I'm using this calculator. But the steps that I use on this calculator will work for any type of calculator. So don't worry if you don't have one. So let's get started. We're going to talk about rounding, which is section 1.2. And I'm going to start by just making up a number. So I'm going to fill in this chart here. And I'm just going to make up some digits, and then we're going to talk about what this number is and then what each of these place values are. Okay, so I'm going to start with just identifying where is the decimal. It's right here. So the place to the very left of the decimal, this is the ones place, and then it goes the tens place, and then the hundreds place, and then the thousands place, and then the 10,000s place, and then the 100,000s, and then we've got millions, and then 10 million. So if I were just to say the number until the decimal, so just cut it off here, it would be 56,421,043. But then we also have some of these decimals. So to the right of the decimal place, the first place is the tenths place. Now this is not tens, okay? It is tenths with THS. So you'll notice the place values to the right all end in THS. And then the 2 is in the hundredths place. And then the thousandths place. And then the 100,000ths place. So everything after the decimal, I would read this number, 0.1267, as 1,267 hundred thousand. So I always go to the farthest place available when I'm saying it out loud. So altogether, this number is 56,421,043, and so I'm just going to write down and is what we say when there's a decimal, 1,267 hundred thousandths. Okay, so let's talk about rounding. So a couple of rules here. So first we're going to ask ourselves, what do we want to round to? What digit are we rounding? And that should be given in the problem. And then you're going to look to the digit to the right of the number that or the place value you're being asked about. If the digit is to the right is 0 to 4, you're going to leave the place value digit alone. If the number to the right of where you're rounding is 5, 6, 7, 8, 9, 5 or greater, then you're going to bump up the place value digit by 1. And then you're going to put in placeholder zeros if necessary. So let's do a couple of examples. So example 1A, we want to round $147.38 to the nearest $10. So we want to look at, what place value is $10. So the ones place is the 7, so that's the ones, and the tens place is the 4. So $10, that would be like saying round this to the tens place. So the tens place is the 4. I'm going to look to the number to the right of that, which is 7. And because that number is 5 or greater, it means we're going to bump that 4 up to 5. So I'm going to leave the 1 alone. I'm going to change the 4 to a 5. And then you're going to put in place value holder zeros to the right of wherever you're rounding if necessary. And the reason I definitely want it's necessary here is if I were to stop at 15 and just put a period there, that would be $15. And we're starting with $147.38, so $15 wouldn't be appropriate. So we want to actually put a 0 there because we want to round $147.38 to $150, okay? So that's the next closest dollar amount if we're rounding to $10. And then you can put a period, you can put placeholder zeros to the right of that if you'd like. They're not necessary after the decimal, but you can certainly put them there if you want to. Okay, so for part B, we want to round. It says the average person's nails grow at the rate of 0.1181, and we're rounding this to the nearest hundredth of an inch. So we start with tens place, hundredths place. So the hundredths place is going to be that second one. Okay. We look to the number to the right because it's 5 or more. It means to bump that 1 up to a 2. So I'm going to write 0.12. And then in this case, you can add those placeholder zeros to the right if you want, or it's not necessary since zeros after to the right of the decimal place, if they're after the digits, it's not going to make a difference or not. So 0.1200 is the exact same number as 0.12. So either one of those would work. If you put either one of those in connect, you'll get it right. So no worries on connect. Okay, so for the next one, we're trying to round this number right here, 65,432,202 to the nearest million. So you want to locate the millions place. So the millions place would be right here, that 5. We're going to look to the number to the right of it. Since it's a 4, it's less than 5. It means leave that 5 alone. So we're going to write 65, and then we're going to put placeholder zeros to the right. So this rounds to 65 million. Okay, and then lastly, is 1 million a lot of money? Depends who you ask. That amount is 0.23749%, so a very small percent of the amount of the federal government spent in 2015 in 1 hour. This is seriously. Round that percentage to the nearest thousandth of a percent. Okay, so I'm going to write down that number, 0.23749%, and I'm going to locate the thousandths place. So to the right of the decimal is the tenths place, the hundredths place, the thousandths place. So the thousandths place is at 7. And then I look to the right of it, which is 4. Since it's less than 5, it tells me to leave that 7 alone. So I'm going to round this approximately. This is a symbol for approximately. It's going to be 0.237. And I could leave it there and just say percent. Or if you wanted to put placeholder zeros, it definitely would not be incorrect, but you don't need them. So our answer is going to be 0.237%. All right. So you've heard me say a percent here in this last problem. That's a good lead in to this next section. So this next part, section 7.1, we're going into a different chapter here, is on percents. So let's talk about what percents mean, and then we're going to talk about how to convert percents. And this section is really important because you're going to see percents throughout the entire course. And so and you're going to see rounding also. So a lot of the stuff in Module 1 is really critical for the entire course. Okay, so percent, what does that mean? So the word per, you can think of that as a translation, just means for every. Okay, and cent, the root of the word cent means 100. Okay, so percent means for every 100. So 1% is 1 out of 100. Okay, if we want to convert a percent, okay, so let's move on to the next page here. So if we're going to convert percent to decimal, so for example, let's say I'm given 33% and I want to know what decimal that is. You're going to drop the percent sign, so you're going to change it to 33, and you're going to move the decimal point 2 places to the left. So you'll notice there isn't a decimal place here when I write down the number 33%. At least you can't see one, but there is. It's always to the right of the number, so you can add it in if you don't see it. And so you're going to take that decimal point and move it 2 spots to the left and get 0.33. Okay, so 33% is the same thing as 0.33. Okay, next, if we want to go percent to fraction, so I'm going to use that same example again. So let's say I've got 33%. Okay. You're going to drop the percent sign, so write 33 without the percent sign, and you're going to put it over 100, okay? So you're going to put that number over 100, and then you're going to reduce the fraction. Now in this case, 33 over 100 can't be reduced, but let's say, I'll give you another example. So let's say we had 25%. We would drop the percent sign, 25, and we put it over 100, And then we could reduce it by dividing both of these by 5. Okay, so 25 divided by 5 is 5. And 100 divided by 5 is 20. You could also divide those by 5 again. And 5 divided by 5 is 1. 20 divided by 5 is 4. You get 1/4. You could also, from the very beginning, 25 over 100, you could divide those by the greatest common factor, okay? And you get 1/4 from the very beginning. So when you're reducing fractions, don't be concerned about, always having to find the greatest common factor. It is possible to just do a couple of steps and get to the same answer. You just want to make sure that you keep reducing, you keep dividing both numerator and denominator by the common factor until you can't do it anymore. Okay, next, so decimal to percent. So let's say, we have our 30.33, that's our decimal. In order to convert that to percent, you're going to move your decimal 2 places to the right. So now we're just going backwards, okay, and add a percent sign. So I'm just going to move it 2 spots to the right, and I've got 33%, okay? And lastly, so fraction to percent, you're going to divide the numerator and denominator and then move the decimal point, okay? So let's say, let's actually do 25 divided by 100. We'll use that example. So over here in my calculator, when you're dividing in the calculator, you can use the division sign here. So a fraction 25 over 100 is the same thing as, whoops, let me clear that out. It's going to be 25 and then divided by 100, enter, and it will give you the decimal for that, 0.25. So 25 over 100 is 0.25. And then we're going to do the same thing we did above. If we want to go decimal to percent, you're going to take that decimal and you're going to move it 2 spots to the right and add a percent sign. So 25%. Okay. So you're going to move 2 places to the right is what you're going to fill in for that blank there. Awesome. Okay, so let's do an example. So example 1, we're going to convert each percent to both decimal form and fraction. Okay, so for 80%, so we're going to drop the percent sign. We're going to write the number 80, and then we're going to take the decimal, which is to the right of the number, and we're going to move it 2 spots to the left. And so that's going to be 0.80. So there's our decimal, okay? And then for our fraction, we're going to take our percentage, 80, and we're going to write it over 100. So 80% is the same thing as 80 over 100. And then we're going to reduce it until we can't reduce anymore. And so I can notice right off the bat, these numbers are both divisible by 10 because they end in 0. So if I divide both of those numbers by 10, I get 8 over 10. And then these numbers are both divisible by 2. So I could divide them both by 2 and I get 4/5. Now I could have just divided 80 and 100 by 20 right off the bat and gotten 4/5 in one step, and that would be totally fine too. So just giving you some options here. Okay, 37.5%. So I'm going to write down 37.5, and I'm going to move the decimal 2 spots to the left, and I get 0.375 is going to be the decimal for 37.5%. Okay, next I'm going to write for the fraction, I'm going to take 37.5 and I'm going to write it over 100, okay, and then I'm going to reduce. Before I reduce though, so this is kind of, this one's a little bit different because you've got a decimal in the fraction. So this is one I would definitely keep this example handy in case you get one like this and connect. If you have a decimal in your fraction, before you reduce it, it's good to get rid of that decimal. And one good trick for getting rid of the decimal, every time you multiply something by 10, that decimal moves 1 spot to the right. So for instance, like if you look over here in the calculator, if you type in 37.5, whoops, typing it in my notes here, hold on a second. Okay, let me get back. Okay, so let me go to my calculator. If we go to 37.5 and you multiply that, whoops, too many 5s. Okay, and then we multiply that by 10. you'll notice it becomes 375 and the decimal goes away. So we can do that. So I can write times 10 here. Whoops, I'm messing this up all over the place. Okay, let's see. We're going to go times, oh, let me see if I can get my pen back here. Hold, bear with me. Okay. All right, so I'm going to write times 10 on the top, and as long as I multiply the numerator and denominator by the same thing, I'm essentially not changing the value of this fraction. So 37.5 times 10 is 375. And then 100 times 10, we basically just add a 0, is going to be 1,000. So if you look over in the calculator, I'll just show you over here that 37.5 divided by 100, enter, you can see the decimal there. That's going to be the same thing as 375 divided by 1,000. You end up getting 0.375 there either, or also. So now what we can do is take 375 over 1,000 and we can go ahead and reduce it. So you could divide maybe both of these by 5. And if you do that, you end up getting 75 over 200. And then both of these are divisible by 25. And you get 6 over 100. And then it looks like, okay, I can divide both of those again. We can divide them by 2 and we end up getting 3 over 50. And at that point, you're done. Now, I will just mention here, if you have the TI-30 or the TI-34 calculator, there is a fraction button. So it looks like this. It's N over D. And if you press that button and put in 375 over 1,000, you can use the simplify key. Okay, I think it's SIMP, and I think there's an arrow. And if you use the simplify key and keep hitting enter, it will actually simplify the fraction for you. So if fractions are not your strongest suit, you know, it's something to consider. So your answer here should be 3 over, oh, and you know what? I wrote down the wrong answer. It should be 3 over 8. 100 divided by 2. Whoops. Oh, you know what? Let me just erase this. I was looking at the 6% here. 75 divided by 25 is going to be 3. And then 200 divided by 25 is going to be 8. So your answer should be 3/8. Okay, so ignore what I just said up there. Sorry about that. I was just looking at my answer key to make sure I wasn't making any mistakes. So you're probably like, what is she doing? So you should end up getting 3/8 there. And just to double check, actually, and this is a really good, you know, because this happens all the time where you make these simple mistakes. Before you put your answer in to connect, go in your calculator and type in 3/8. So I'm going to come over here and I'm going to type in 3 divided by 8, and I should get the same decimal. And I do, I get 0.375. So that's a really easy way to just check your work. Okay, so 6%. Let's talk about that. So we're going to write the number 6. We're going to take our decimal, which is to the right of the number, and move it 2 spots to the left and get 0.06. So that's the decimal. And then for the fraction, you're going to write 6 over 100 and reduce it. And that actually reduces to 3 over 50, which is what I originally put for part B because I was looking at the wrong answer. But if you divide both of these, we could divide both of these numbers by 2. You end up getting 3 over 50. And then let's use our calculator to just double check here. So if we do 3 divided by 50, enter, we get 0.06, which is perfect. Okay, cool. So for example 2, now we're going to convert each of these to a percentage. So this just means we're going to move the decimal 2 spots to the right. So take the decimal, go 1, 2, so 47.2%. 1, 2, 103%. 7/8, you're going to do 7 divided by 8 in the calculator. So let's go ahead and do that. So 7 divided by 8 in the calculator, you end up getting 0.875. And then we can move our decimal 2 spots to the right for 87.5%. Okay, same thing with 5/6. You're going to do 5 divided by 6. So 5 divided by 6. Whoops, I'm typing in my notes here. Let me go to the calculator. 5 divided by 6. You end up getting, oh, we've got a repeating decimal. So this is a good one to talk about. So 0.8. So why is my pen not working here? Okay. 0.83. 3333. So the way I'm going to write this is 0.83 repeating, or let me write it out so we can get the percent here. When we're doing the percent, we're going to move our decimal 2 spots to the right. So 83.3. And I'm going to stop there and put a repeating bar over the 3. Percent. We could also say 83%, and we could repeat it there. Either one is okay, and I would just pay attention to the directions on the connect. If it says round to the nearest percent, then you'll just put 83 repeating percent, or if it says round to the nearest tenth of a percent, then you'll do 83.3 repeating percent. So it really just depends on how you're asked to round there. So either one of those answers should end up working. Okay, so let's do a couple of problems involving percent. So we're going to go and do some word problems here. So the most common calculations involving percents involve finding a percentage of some quantity, okay? So when you see things like percent of whole equal parts, okay, that's that translates in math form to a percentage. So in this case, we've got 50%. This is like 50% of 10, okay? So 50% is the percent, 10 is going to be the whole, equals, so half of 10, or 50% of 10 is 5. 5 is going to be your part. So let me say that again. So a percent of a whole is equal to a part. So 50%, this is just an example, 50% of 10 equals 5. 10 is going to be your whole, 5 is going to be your part, okay? So for example 3, let's just jump into an example. So according to Fast Staff Travel Nursing, around 9.1% of all registered nurses in the U.S. are men. The average hospital in 2016 had 347 registered nurses. How many would likely be male? So we need to find 9.1% of 347 nurses. Okay. Of in math means times. If you want to find a percentage, you're going to take the percent as a decimal. So you're going to take that decimal and move it 2 spots to the left. So now you can see why we did all that work doing the conversions, because you're going to need it with the story problems. So we're going to say 0.091. You always put a placeholder 0 if you don't have any number there when you move your decimal. So 0.091 times 347. So we made our percentage a decimal, and then we multiplied it by the whole to get the part. So 0.091 times 347 is 31.577. In a problem like this, you're likely going to be asked to round. So let's say it asked you to round to the nearest whole number. You would say that's about 32, since the nearest whole number is the same thing as saying round to the nearest ones place, because you want to eliminate the decimals. And so I'm going to look to the right of that, and since it's a 5, we're going to bump that one up to a 2. So approximately 32 male nurses in that bunch. Okay, let's look at example 4. So we've got a medium-sized company reported that it had to cut its workforce back to 70% of what it was last year. So 70% of last year. Okay. If it has 63 workers now, how many did it have a year ago? So 70% of last year is 63 now. Okay. So 63 is like your part. The last year, that's like your whole. Okay. So let's write this out in an equation. So we're going to say 70% of last year equals 63. Okay, even better, I'm going to write 0.70 as a decimal, because 70% is a decimal. We move that decimal 2 spots to the left. So 0.7 times last year, let's just call that x, is equal to 63, and then we're going to solve. And the way we solve is we always do the opposite of what's being done. So if x is being multiplied by 0.70, you're going to divide both sides by 0.70, and you end up getting 90 workers. Okay, and then always ask yourself, does that make sense? does 70% of 90 equal 63? So you can always come over to your calculator. It's a really good idea. And just do 0.70 times 0.70 times 90, enter, and you end up getting 63. Awesome. So we got the right answer. Okay, so let's jump into example 5. So example 5 says a real estate agent receives 7% commission on all home sales. How expensive was the home if she received commission of $5,775? Okay, so she is receiving 7% commission on all home sales, which we don't really know what that is. So I'm just going to write all home sales. And that's equal to a commission of $5,775. Okay. This is like your part, and this is like your whole. Okay. Now I'm going to write 7% as a decimal. So that's 0.07 times all home sales. That's what we're trying to find. I'm going to write that as an X equals $5,775. And then I'm going to solve. I'm going to solve by dividing both sides by 0.07 because then these cancel out and leave X by itself. And then when we divide those two numbers, we end up getting $82,500, okay? And then again, you can double check on your calculator. So if I come over here on the calculator, we can just check by doing 82,500, and then we'll say times 0.07 equals, we end up getting $5,775. Awesome. Okay. So the next thing we're going to talk about is percent change. So there's several questions on Connect that ask you to find a percent increase or percent decrease. So like they'll give you some amounts and they'll ask, what was the percent increase, or if some numbers went down, what is the percent decrease? Basically, all you have to do is to find the percent increase is you're going to take the amount of the increase and you're going to divide it by the original amount. Okay, and we'll do an example. Let's just write these formulas down and then we'll do an example. For decrease, we're going to find the amount of the decrease and we're going to divide that by the original. Okay, and then you're going to change the fraction to a percent by dividing and moving the decimal 2 to the right. Okay, so let's look at example 6. So a large latte at the Caffeine Connection sells at a regular price of $3.50. So when it says regular price here, that's like our original price. And I'm labeling that just because in the formulas we have, we need to know what that original price is. Today it was on sale for $3. So it went down. Find the percent decrease. So I'm going to find the amount that it decreased. Okay, and divide that by the original price. So it decreased, let's see, we're going to take our original, so $3.50, and subtract $3. That tells us how much it went down by. $3.50 minus 3 is 50 cents. So it went down 50 cents, and the original price is $3.50. So you'll see in this one, you see that $3.50 is repeated both in the numerator and the denominator. So when you divide these numbers, so I'm going to take 0.50, so 0.5. Oh, there we go. Okay, I'm going to come over my calculator here, and I'm going to go 0.50 divided by 3.50, enter, and I end up getting this fraction. So I'm going to write down a lot of, or I'm sorry, not fraction, we get this decimal. I'm going to end up writing quite a bit of this decimal down. I think that's good practice. And then just ask yourself, what are you asked to round to? So in this case, round to the nearest tenth of a percent. So I'm keeping a fair amount of those decimals, and then I'm going to move my decimal 2 spots to the right for my percentage. Okay, so I get 14.2857 percent, but then it wants me to round to the nearest tenth of a percent. So notice I converted to a percent first, and then I look for the tenths place. So the tenths place is this 2. So I look to the right of it, an 8. So that tells me I'm going to need to increase that 2 to a 3. So my answer is 14.3%. So that's the percent decrease. So you could kind of think of that as that being on sale, 14.3%. Okay, so we're going to transition now to section 7.2, which is personal budgeting. So budgeting is just the process of deciding how much money you can spend on various expenses based on how much you're taking in or your income. And one thing that's really important is to figure out how much you're actually taking home, because it's one thing to see on your check how much money you make, but usually most people are paying taxes when they're getting those checks. So you want to know actually how much you're taking home, not how much your employer is actually paying you before taxes. So let's look at example 1. So it says Marlene works full-time as an executive assistant, and she has a check for $1,023.07 direct deposited every other Friday. Okay, what is her monthly take-home pay? So one quick way to estimate this would just be to say, okay, well, she gets this $1,023.07 every other Friday. You could just double that and say, well, there's usually 4 Fridays in a month. This varies depending on the month, but usually, you could just take that number, so 1,023.07, and you could just double it. That would be a really quick estimate. So if you're just estimating, that would be a really good way to do it. We can be a little bit more accurate though, because not every month necessarily has four Fridays. So we've got months with different days. So an accurate way to calculate this, and this is how you're going to be asked to do it on Connect, is to figure out the daily rate. And then we're going to figure out how much she makes per year and divide it by how many months you have. So let me just go through that. So step 1 is we're going to find the daily rate. Okay, and we're going to do that by taking the $1,023.07. She makes that every other Friday. So that's what she makes. That's basically saying for 2 weeks of pay, and 2 weeks is 14 days. So I'm going to divide that by 14 to figure out how much she makes a day, and I get 73.08. So that's her daily rate. Okay, next I'm going to find out how much she makes in a year. Okay, so I'm going to take her daily rate, so 73.08, so 73.08, and multiply it by 365, that's days in a year. Okay, and I get 26,674, so 26,674.20, and that's how much she makes per year. And then if I want her monthly pay, I could take that amount and I could divide by the number of months, okay, in a year, which is 12. So 26,674.20 divided by 12, and I get $2,222.85 per month, okay? And if you notice, this number is different than what we estimated up here. Because, there's not exactly 4 Fridays in every single month. There's different amount of weeks depending on what month it is. So this calculation that we did below is much more accurate. And you can see she actually makes more than what she estimated above, which is always nice. Okay, so let's look at example 2. So calculating the sum of some regular expenditures. So this is helpful because we all tend to buy these things, and sometimes it's, it seems like no big deal to spend $3 on a cup of coffee, but it's nice when you can calculate how much you're going to spend for an entire year. Sometimes that dollar amount ends up looking a lot bigger than what you thought it was. So if you spend $3.25 for a cup of coffee, and you buy 2 of them every single day, so $3.25 times 2, how much are you going to spend per year? So that's per day, and there's 365 days per year. Make that a 6. If we multiply those all together, that's $2,372.50 per year. Holy moly, that's a lot of money on coffee. Looks a bit different when you've got that yearly sum here. So for B, we're spending $4.79. That'd be expensive Burger King 3 times a week. So $4.79 times 3 weeks, every single week for a 16-week semester. So there's 3 days a week and then 16 weeks in the semester. You'd be spending $229.92 on Burger King for that semester. So kind of nice to just look at it as a sum because it gives you a better idea of how much you're spending. So let's talk more specifically about expenses. So we have a couple different categories in terms of expenses. So we call luxuries things that you can live without. So for example, types of entertainment. Maybe you go to Starbucks. Okay. Maybe get your nails done. Stuff like that. Necessities, which are different than luxuries. So those are things that you have to pay for, like food, shelter, insurance, things that are more essential to living. So fixed necessities would be expenses that have consistent amounts. So expenses with consistent amounts. So that would be like your rent every month. That would be like your car payment. That would be like, insurance. Variable necessities are expenses that can vary and that do vary. So for example, how much money you spend on food every month, how much money you spend on clothing. These things are going to go up and down depending on the month. So example 3 asks us to figure out, it says Tremaine brings home $2,146.79 per month and has the fixed expenses shown below. So these are all fixed expenses that he has. How much can he afford to spend on food, clothing, and luxuries? So let's go ahead and add up all of these amounts. So if we add up all of these amounts, so I already did that in my calculator, and you can pause it and add it if you'd like. I get $1,497.76. So that's the total for his fixed expenses. Okay. If I want to know how much he has left, then I'm just going to take what he makes and then I'm subtract his expenses. Okay. And then I've got $649.03, and that's going to be what he has left over to spend. Okay. So we add up the expenses and then we subtract them from the income that he makes per month. Okay. One strategy that can be helpful is to prorate long-term expenses so that you can budget money and put aside money for larger expenses. One example of this might be like car insurance. Like if you have to pay car insurance twice a year, maybe it's $1,000 twice a year. Instead of thinking of it as, oh, I have to pay it every 6 months, kind of prorate that and say to yourself, well, how much would I have to pay every month? So you know what to save so that, every 6 months you're not shocked when you have to, make that huge payment. So let's look at this example. So it says Jen pays $337.24 every 6 months for car insurance. So I'm just going to write this down. So for car insurance, $337.24 every 6 months. Okay. And so this is every 6 months. Okay. And at the end, if we look at the actual question, it says if he wants to plan ahead, how much money should he put into savings every month? So you know what I'm going to do is I'm going to divide that car insurance by 6 to figure out how much he should be saving every single month. So $56.21, that's per month, what that would cost. Okay, so next I'm going to write down tuition. So for tuition, at the beginning of both fall and spring semesters, he budgets $650 for books and supplies each semester. So I'm going to write $650. Oops, you know what? That's not tuition, that's books. Sorry about that. Okay, getting ahead of myself. So $2,623. So $2,623. But that is for fall and spring. So I'm going to multiply that by 2. I get 5,246, and then I want to know how much that would be per month. So I'm going to divide that by 12. since that's how much he pays per year in tuition. So $437.17 a month. Okay. And last, now I'm going to go to books and supplies. So it says here that he spends $650 for books and supplies each semester. So there's 2 semesters, it says, so that's going to be $1,300. But I want to figure out how much he needs to spend per month on that, or save per month. So if you divide that number by 12, you get $108.33 per month. So now he can look at, okay, well, how much total should he be saving every single month? So every month we're going to put it all together. So I'm going to say total. I'm going to add the $56.21 from car insurance. I'm going to add the $437.17 for tuition, and then I'm going to add the $108.33 for books, and it looks like that's $601.71 per month. And just as a side note, most banks will actually allow you to do automatic transfers. So let's say if you have a savings in a checking account, you can, and maybe all of your money goes into your checking account, you can actually automatically every single month transfer a certain amount to your savings. And that would be a great way for this person. You know, he could just transfer that $601.71 every month. So that way he's got money saved for when those bigger bills come in. Okay, so we're going to transition now to section 7.3, which is on simple interest. So this is the last section of the of this module. So simple interest, let's just first talk about what interest is. So interest is a fee charged for the use of money. So if you're borrowing money from, let's say, a bank, a lender, they charge you interest, which is basically just money that you have to give them in order for the service of them loaning you this money. So let's just let's do this example right here. So what is the interest if your friend lends you $20 and you pay him back $25? Well, if they lend you $20 and you paid him back $25, there was $5 extra. So that's $5 that you had to pay in interest. Okay? What is the interest you pay if you pay $4,000 in payments for a car that you could have bought for $2,800 in cash? So let's just subtract those two numbers. So if you paid $4,000, but really you could have paid $2,800 if you paid in cash, there's a $1,200 difference. So that's the interest that you end up paying for the service of being able to pay in payments instead of paying in full. And basically, you know, let's just talk about real quick the difference between the types of interest. So we've got simple interest and then compound interest. So simple interest is just a one-time fee or percentage of an amount of money. So you're paying this interest one time. So those two examples we just went through, those would be examples of simple interest. Compound interest, on the other hand, is when the bank or lender is taking a percentage of an original amount as well as a percentage of each new amount, including previously calculated interest. So basically, we'll talk about this more in the next module, but with compound interest, your interest is going to add up much more quickly. So an example of this might be a credit card. So let's say you have $30 on your credit card, an outstanding balance. Well, you're going to pay interest on that. So maybe that $30 now becomes $45 because you pay $15 in interest. Okay. Well, if you leave that $45 on your credit card and you don't pay it again, that's going to jump up a little bit more. So maybe you pay, instead of $15 in interest, maybe you pay $18 in interest again. Okay. So that would be like $63 here, would be your new balance. And so every single time, every single month when there's an outstanding balance, there's going to be an interest amount on the previous balance. Well, that previous balance included other interest. So you're essentially paying interest on your interest, which means that it adds up really, really quickly. So with things like credit cards, it's really important that you just pay as quickly as you can, which we all know, but it's good to be reminded. So let's talk about some different parts of the simple interest formula, and then we'll do some examples. So the formula for simple interest, I'm just going to fill in this blank here, is I equals PRT. Let's talk about the parts. Okay, so I, that's going to be your interest. P is going to be your principal. Okay, and you can see that above here. Principal is the amount of money borrowed. R is going to be your rate, and that's always as a decimal. And T is going to be the time, and that's always in years. Okay, really important because sometimes the problems will give you the months, and you want to make sure you calculate for years. Okay, so if you want to find the future value, okay, and again, future value is the amount of the loan plus the interest. So like the total basically that you have to pay back. You're going to take your original principal, okay, what you're borrowing, and you're going to add the interest. Okay, so let's say you borrow $5,000 and you have to pay $1,000 in interest, then the future value would be $6,000 because that's the total you have to pay back. Okay, so let's go down through to example 1. So find the simple interest and future value for a loan that's $3,600 for 3 years at a rate of 8% per year. So as soon as you see simple interest, let's write down that formula, I equals PRT, and fill in what we know. So the $3,600, that's going to be your principal. It's asking you to find the future value. So we'll do that through this process here. So $3,600, that's going to be your principal. 3 years, that's going to be your time. So T equals 3. And 8% as a decimal. Okay, we're just going to move that decimal 2 spots to the left. So R is going to be 0.08. So let's plug in what we know here. So the interest is going to be 3,600 times 0.08 times 3. And if we multiply those all together, we get 864, and that's the interest amount. Okay, notice it didn't ask for the interest though, it asked for the future value. So that's like, what do you end up having to pay back altogether? So if we look at that formula, which is this one up here, we're going to take the principal and add the interest to find the future value. So the principal was $3,600 plus $864. You end up getting $4,464 altogether. So that's going to be your future value, or what we call A. Okay. So let's look at example 2. So to meet payroll during a down period, United Ceramics Incorporated needed to borrow $2,000. So if they're borrowing, that's going to be your principal at 4%. So 0.04 is the rate for 3 months. Now, anytime you see the word months, a red flag should go up off in your head, and you should think, okay, well, T is normally in years, so I'm going to have to convert that. So ask yourself, well, how many years is 3 months? Well, you can always just take the months and divide by 12 because there's 12 months in a year. So 3 divided by 12 is 0.25, and you can use a calculator for that. 3 divided by 12, 0.25. That's going to be your T. So I'm going to write down, it asks for the interest. So I'm going to write down my formula, I equals PRT. So the interest equals $2,000 times 0.04 times 0.25. And you're going to multiply those all together and get 20. And unlike the last problem, we're not asked for the future value. If we were, we'd add the 20 and the 2,000, but in this case, we're just asked for interest. So we're actually done with that one. Okay, so let's look at example 3. And I know I said this in the beginning, but this would be a great time to just, make sure you're stopping the video with these examples, try them yourself, and then press play to see if you're on the right track, okay? So we've got Admiral Chauffeur Service. They borrowed $600, so that's P, at 9% simple interest. So rate equals 0.09, because I'm going to take 9% and move the decimal 2 spots to the left, okay? For 1.5 years. So I'm going to write that as a decimal. So instead of 1.5, I'm going to write 1.5. Find the interest, future value, and the monthly payment. So we've got something else here, monthly payment, that's new. So the first thing I'm going to do is I'm going to write down the formulas I know. I know that interest equals PRT, and I know future value is the interest plus the principal. Now, I don't know what the interest is, so I can't use that future value formula yet. So I'm going to start, my step 1 is going to be use this interest formula and plug in what I know. So I've got a $600 principal, a 0.09 rate, and a year of 1.5. When I multiply those all together, I get interest of $81. Okay, so that's the first part. Now, part 2, I'm going to find the future value. So I'm going to take my interest, $81, and I'm going to add it to my principal. So I get $681. That's my future value. That's what I end up having to pay back. So I borrow $600, or this chauffeur service does, and I end up having to pay back $681. And then for the monthly payment, okay, all you have to do is to take your A value, okay, your future value, the total that you end up having to pay back, and you divide by the number of months in the loan, okay? If they're paying this, or if they're taking this loan out for 1.5 years, okay, then that would be, we can find the months in 1.5 years. So 1.5 years would be like 12 months in a year, and then another 6 months for a half of a year. So that would be like 18 months would be a year and a half. And then our future value is 681. So if I take what I have to pay back, 681, divided by the number of months, 18, I end up getting $37.83 per month. And that's my monthly payment. Okay. So let's go down. We've got 2 more examples left of this module. So for example 4, okay, this is a little different one because this question asks for the rate. So we haven't done one like this before. So we've got this furnace company. They invested $15,250 for 10 years. So in this case, this isn't a loan, this is an investment. So the initial investment is the principal, just like the amount borrowed is the principal. So we can use the same formulas for investing or borrowing. For 10 years, so I'm just going to write T equals 10, and they received 9,150 cents in simple interest. So that's going to be my I. What was the rate? So let me write down, it says simple interest. So I write down my simple interest formula. So I equals PRT. Some people say this is the PERT equation, so just to help themselves remember. And let's plug in what we know. So 9150 goes in for interest. 15,250 goes for principal. I don't know what rate is, and time is 10 years. Okay. So how do you solve this? So we want to get to this rate. We're solving for that. So with multiplication, we've got 3 things that are multiplied here on the right-hand side. Multiplication, you can multiply in any order. So for example, 2 times 3 times 5 is the same thing as 2 times 5 times 3. You can move those around. It's called the commutative property that allows us to do that. So what I would suggest here is just to multiply that 15,250 by that 10, okay, and we get 152,500, essentially just adding a 0. R equals 9150, and then we want to divide both sides by the number in front of the variable so that that goes away. And whenever we do to one side, we do the other. And so when we divide those 2 numbers on the left there, we end up getting 0.06. And depending on, so you could just got to pay attention to connect and what it asks. If it asks for the rate as a decimal, you'd type in 0.06. If it asks for a percentage, then you'd take 0.06 and you move it 2 spots to the right, and you'd say 6%. And you'll always know in connect, it should say in the directions, and then the box that you enter the answer, you'll see if it's a percentage, it'll actually have a percent sign next to it. Otherwise, if it's not a percent, then it won't have a percent. So just pay close attention to what the directions say. All right, so last but not least, we've got one more example here, example 5. Okay, so for a new set of tires, which cost $412.23, Frank financed the tires for 1.5 years at low monthly payment of $28.80. By the way, they always say it's a low monthly payment, so you got to watch out for that. Find the interest rate, round to the nearest 100th of a percent. Okay, so if we want to find the interest rate, let's write down our formula that has the R in it. So I equals PRT, okay? And let's think about what we know. So we know that the time is 1.5 years. The set of tires cost $412.23, so that's going to be the principal. So I've got the principal is $412.23. I don't know the rate. The time is 1.5, okay? What is the interest? We actually don't know. So this is how I kind of start problems. I write down the formula, I put in what I know, and then I say to myself, okay, so I can't have a formula of 2 variables. I can't leave the I and the R there. I want to know the R, so I have to figure out what that interest is in order to solve. So I'm going to just leave that there, and I'm going to come over to the side, and I'm going to think about what I know about this monthly payment. So if this person's paying $28.80 per month, okay, for 1.5 years. So 1.5 years, we actually did this in the last problem, is 18 months. So this person is paying $28.80 for 18 months. So let's figure out what this person is paying altogether. So $518.40, okay? That's like the future value. So if you're a person that likes formulas at this point, you could say, oh, well, I have a formula for that. The future value is just the principal plus the interest. So if the future value is $518.40, and I know the principal is $412.23, then I can easily find the interest there. Or just, think about this. You don't even need the formula, really. If the person's paying $518.40, but the tires only cost $412.23, find the difference between those two numbers, and that will give you the interest. And that's exactly what we're doing here with the formula. So if we subtract those from both sides, we end up getting an interest amount of $106.17. Okay, so that number is going to come over here to the interest. So I'm going to write 106.17 equals 412.23 times R times 1.5. And now it becomes a problem that's very similar to what we did above. So I'm going to take these two numbers and I'm going to multiply those. So I get 618.345 R equals 106.17. And then you're always going to divide both sides when you have an equation like this by the number in front of the variable, because you want the variable to be by itself. And when you take a number and divide it by itself, you end up getting 1. So that's why we say it essentially just goes away, because 1 times any number is just itself. So if you divide those two numbers on the left-hand side here, 106.17 divided by 618.345, you end up getting 1.1717002, okay? And it says to round to the nearest hundredth of a percent. So the first thing that I would do is actually make that a percentage. So I'm going to take this decimal and move it 2 spots to the right, so 17.17002%. And then I'm going to identify, well, where's the hundredths place? That's right here. I look to the right, it's a 0, so that means leave that 7 alone, and those digits at the end there go away. So 17.17% is the amount of interest that this person paid in order to make monthly payments. It's a pretty high interest rate. So it's always good to, look at how much you're paying total and the interest rate, rather than just looking at how much you're paying per month, because, oftentimes you'll be surprised how much you're being charged for a certain item. So I hope that helps. As always, let me know if you have any questions. I'm here to help.